So what I'm going to do is I'm going to talk about mathematics that we teach you in Aberystwyth, but also before that I'll try and sort of summarize what Robin said about the motivations for studying mathematics, and then think about the various ways that we can help you to achieve your goals. Okay, so I'm not only a mathematics lecturer, but also the admissions tutor for mathematics. So I'm more than happy to answer a few questions if there is time on that. Okay, so to summarize, why study mathematics? Well, as Robin indicated, it underlies all of the sciences and many aspects of business and industry and commerce. So these pictures here are meant to remind me to talk about the various newsworthy ways that mathematics has played a part in developing physics, for example. So you may have heard of gravitational waves caused by here the collision of two black holes. And this year, actually, the Nobel Prize for Physics was awarded to Sir Roger Penrose for the mathematical developments that led to the prediction of black holes. So he demonstrated how Einstein's general relativity, theory of general relativity, was devised over 100 years ago, led to the prediction of a black hole, which was only very, very recently, about 2 years ago, pictured for the first time. So this fairly unassuming picture in the middle here is the first ever picture of a black hole. And the areas of mathematics that I'm interested in include topology, and this is a very abstract area of mathematics. I'm a pure mathematician, but I'm also inspired by the ways that mathematics and physics in particular interact. And yet another Nobel Prize, a set of Nobel Prize winners were awarded their prize in physics for realizing that this very abstract area of mathematics called topology, which is an area where you can think of it as analyzing shapes, but features of shapes that are not dependent on that particular shape. So they're not dependent on whether you can, after any kind of smooth deformations or bending or stretching and things like that. The kind of things like for example, you can't tell the difference between a donut and a coffee mug if you're a topologist. That's the cliche, because each one is a surface that has only got one hole. And they use ideas like that to advance their ideas in material physics, and were awarded Nobel Prizes. So it's fundamental in all of sciences, and also in the financial market. So here's the Black-Scholes model you may have heard of, partial differential equation, that you study in the third year in the stochastics models of finance modules at Aberystwyth. That allows one to model financial markets. And also abstract mathematics, which is close to my heart, in number theory, modular arithmetic in particular, underlies internet security. So you may have heard of the RSA algorithm, and that uses the abstract mathematics that you will be taught in the second year of your mathematics course at Aberystwyth. Okay, so it's a fundamental subject, and which opens up many doors and a wide range of also you may be also interested in highly paid career options, as Robin mentioned. We will enable you, hopefully, to achieve your career goals by providing you with excellent training and what I would say is creative problem solving, and as also as Robin was mentioned, clear, precise, and logical thinking. So that's our goal, is to teach you those skills, or help you really to develop those skills. So why did I study mathematics? Well, to be honest, it wasn't because of a career option that I had in mind. I just simply loved mathematics, and I think that's a perfectly good reason to study mathematics at university. Indeed, if you weren't interested in mathematics, if you didn't enjoy problem solving, then you're going to have a pretty hard time in studying mathematics at university. So I assume that all of you here have got a pretty good interest in problem solving and logical thinking and so forth. And so this will be an intellectually challenging and hugely rewarding exercise for you for studying mathematics. Essentially, it's fun. Okay, so we study mathematics because it's fun. It's frustrating at times, but we have that eureka moment where everything clicks and comes together, and the world is put to right, as it were. So that's what we will help you to study, well, help you to realize, as it were, to encourage you to think creatively, to solve problems in a fun way. So how do we do this at Aberystwyth? Well, we pride ourselves very much on being student-facing, I would say. We really do have the students in mind from the get-go. We're a small enough department, as you saw, in a small enough town, as it were, to have a personal approach. I think this is a big advantage. So you're definitely not a number, as it were, in the mathematics department. You get to know your lecturers and your tutors, and that enables a sort of a very healthy interaction that furthers your learning. But we're also all research active. So just sort of a quick mention about the research that we do at Aberystwyth. So there's three main groups. I'm a member of the Quantum Structures Information Control Group because I've got a particular interest in non-commutative topology, as it's known, sort of an operator algebraic approach to topology. And we also have colleagues working on mathematical modelling, which I'll mention a little bit later, and in statistics. So all three areas, essentially. So the quantum structures is underpinned by very pure abstract mathematics, and the mathematical modelling is more traditional sort of applied mathematics, and the statistics, of course, is statistics. So that's the research that inspires our teaching, and as Robin has already indicated, we score very highly in terms of student satisfaction, and also for satisfaction in mathematics also. So you can see, you may have heard of the National Student Survey. These figures of 100% across all of these areas, okay, admittedly they're from a few years ago, but that's pre-pandemic, as it were, figures. If you go to the discovery uni.co.uk, so let me just see if I can just swap to that very, very quickly here. So if you go to that website, and you may already have done so, and you'll notice that for mathematics, so the single honours mathematics course, you'll see, again, this year, latest data, based on 2019 and 20 data, 100% student satisfaction, 90% of our students go to work within 15 months of finishing the course, and you'll see a load of high 90s, 100% across the board. So I'm not sort of cheating you by telling you about the last 2018 data. It's fairly constant, as it were, that we have these high satisfaction scores. Okay, so to run through the degree schemes that we have already, that we have on offer, Robin has already indicated many of them, so I'll go through this very, very quickly. So there are three-year single honours courses in whatever flavour of mathematics you wish to study, as it were, including a course dedicated to mathematical modelling. We really do have world-leading experts in mathematical modelling. You may want to check out, as Robin mentioned, the Aberystwyth video on mathematical modelling. That's Professor Simon Cox, who's the head of the department, who you see here, and Dr. Kim Knoby, our statistician, one of our statisticians, made fairly recently. So these three-year courses you would study, and after which you'd get a BSc, but you can also study for a further year in mathematics and get a Master of Mathematics. That's really valuable qualification to have. You get the benefits of having a master's level qualification, but using undergraduate sort of level funding, or got access to undergraduate funding options as well. We also have mathematics with a year in industry. So here you go out and have work experience as part of the course with a range of companies that offer placements, as it were, and the mathematics of the foundation year probably isn't so relevant to those of you here today, maybe, but if you haven't got that, the entry requirements to go into the three-year courses, then we provide you with essentially the mathematics that you could meet at A-level within a year in order to bring you up to the level of knowledge that's required to enter into the three-year courses. We also have specialist schemes in financial mathematics, some of you may be interested in that today, in data science, as Robin said, and mathematical and theoretical physics, which is the area that I'm particularly interested in. And we've got four-year versions with year in industry and the foundation year options as well there. We've also got the MMath in mathematical theoretical physics. Okay, so more about that in the link provided here or through the courses.aber.ac.uk webpage. We can combine mathematics, as Robin said, in joint honours or major minor schemes in various subjects as well. So I know that some maybe want to do mathematics and education, which is a valuable course to do if you are interested in becoming a teacher, and mathematics and economics and business and economic finance and so on, if you want to go into the financial sector. Of course, the financial mathematics may also be a great option for you there as well. Okay, so Year 1 modules are listed here. So the idea here with Year 1 is to essentially provide you with the basic sort of set of knowledge that's required by every good mathematician, as it were, before progressing on to the more advanced modules in the second part of the degree, which is in Year 2, 3, and maybe 4, where you can specialise as you go along each year. So if you were studying the G100 Mathematics Single Honours course, you would do all of these modules, plus another 1 or 2 modules in a subject of your choice. So there are 20 credits, as it were, of elective modules for you to choose from. You could choose to continue your interest in physics or computer science, or indeed a language, Welsh, French, German, or indeed you could take some other mathematics modules. Now the colour coding here is meant to indicate, for those of you who are interested in a joint honours course, you would study the pure mathematics, which is in blue, and also the green, either the green applied route or the red statistics route. Okay. So that's a choice you would make when you first register here at Aberystwyth, and that would be the stream that then you would follow throughout the 3 years that you're here. We also offer a career and planning skills development course in the first year, and so this is because I think it's very important to start thinking about your future career at the earliest opportunity. Now, it doesn't mean to say that you've fix things in stone, as it were, but you start thinking about it, you chip away, and maybe it's a process of elimination. As Robin has already indicated, there's a huge variety of things open to you as a mathematics graduate, and this course helps you to sort of sift through those various options to see what's right for you, and also provide you with the skills that graduate employers are really looking out for, such as teamwork, coding skills, presentational skills, and sort of more problem-solving skills in the context of solving a problem and then communicating your findings to a small group of your peers, as it were. So it's all done in a very sort of relaxed sort of environment. There's nothing to be sort of concerned about sort of learning these new skills. Think of it as a safe environment to try out the skills that you probably need in the graduate workplace. So those are So solving mathematical problems and presenting your findings is a key component of that course, and along with the coding. So I'll mention a little bit about coding later on as well. So one of the other elective modules you might be interested in studying in the first year is our games, puzzles and strategies module. Now, this was developed because of this increasing demand for graduates that are skilled at problem solving and, importantly, as I keep on sort of stressing, communicating your findings to your colleagues in an understandable way. So the idea is you gather all this complicated information together, you do your analysis, could be very complicated, but then you have to communicate that in a way that's understandable by various audiences. So that's a key skill to have. It's one thing to understand what's going on and to do the mathematical analysis, it's another thing to communicate it. So that's what would help you to do yet again in this kind of module, but in a pretty fun way, as it were. So we analyze various games, and you get to meet various lecturers. It's a good way of meeting lecturers and fellow students in the sort of group work that you'll be doing as part of this module. Each lecturer will present a game they're interested in, present a little bit about the mathematics required to analyze the game and the various strategies that you may think that you may want to sort of think about developing, and then it's up to you then to play the game, analyze the game mathematically, and come up with various strategies, and then disseminate your this information that you found through presentations or posters and pamphlets, or maybe even developing some apps that you might want to sort of demonstrate how to play the game. So that's one to look out for in the first year. The second sort of second year and third year modules are listed here. Again, it's the blue, the green, and the red are meant to indicate pure mathematics, applied mathematics, and statistics broadly. Now, the third year modules in particular is where you can really specialize. And here, these modules here tend to follow the research interests of staff. So when you're looking through various mathematics courses, the first 1 or 2 years are going to be fairly standard. They're going to be many modules in common, the algebra and the calculus and so on. But in the third year, that's where we have a chance to really talk about well, we're all passionate about mathematics, but there are certain areas of mathematics we're more passionate about, even more passionate about. So I, for example, am extremely passionate about operator algebra, and I work on topology as well. And so I teach, and I'm involved in teaching of operator algebra and topology. And so, as I said, all of our members of staff are research active, and their research interests flavour these third year and fourth year modules. So, as an example of a new module that we're putting on for the first time next year, in the third and fourth year, is quantum information theory. So information theory is an exciting sort of area at the moment. Indeed, some physicists believe that the whole reality is based on information rather than sort of what you traditionally think of as physical matter and so forth. So the transfer of information is extremely important, and the beginnings of it was in Shannon's seminal paper, A Mathematical Theory of Communication, back in 1948. But the amazing thing he did was to create a mathematical framework for information theory. And this is what you start to study in the third year version of the information theory module. And in the fourth year, in the MMath, master's level version of this module, you would start to learn about the quantum information theory. That's a really exciting area. As Robin very helpfully indicated already, we've got this Aberystwyth or Aberhub website, which holds all these various interesting videos, and one of which is the Challenges of 2030 Mathematics Quantum Computing video, which is given by one of the lecturers on this course, and gives you an idea of how quantum computing is the next generation of computing based on quantum information theory, based on the small scale, the best model for the range of the small scale that we have in physics, as it were, how that's going to impact on future generations of computing. Okay, check out those. And then just a quick mention that, well, how do we deliver all of these modules? Well, we deliver them through sort of traditional lectures, but also workshops and small group tutorials, very much so is a big feature in the first year. You'll be given loads of learning resources, as you'll see. This is why we have 100% satisfaction for learning resources, as it were, all put on our websites, dedicated websites for the modules. You'll see lecture notes. We record every lecture. There'll be additional videos to strengthen your understanding of particular topics, and maybe revision videos, and information sheets. All the assessments and the exercises will be delivered through the module web pages, and you'll have access to past exam papers also. So everything is very conveniently at hand, but also we don't leave things online, as it were. We've had enough of this online environment. We want to sort of get into sort of in-person teaching again, as it were, and that's a very big feature of Aberystwyth. The additional support that we offer. So we have help desks, we have an open door policy for our lecturers. You will get to know your lecturers fairly well, so you will be very comfortable in approaching the lecturers, which is very much encouraged to have that sort of two-way discussion in supporting your understanding of mathematics. Okay, so a quick word about links with industry before I pass you over to Jack, Patience and Aled. So just to mention that we have various links with various companies. So for example, Syntef here is one of the leading independent research companies in Europe. And there, our researchers are working with them to model things like fluid-solid interaction for carbon dioxide sequestration and in medicine and so forth. So another nice sort of example is the contract that we had with BTG, which has become BTG Specialty Pharmaceuticals. They needed a mathematical model for how foams flow through veins in our body. And they were developing this foam that would help in the treatment of varicose veins. But so the idea is that this mathematics here is essentially the same mathematics as used in the various scenarios in various contexts. And that's the beauty of mathematics, is you develop a mathematical model that can be applied universally, as it were, in a wide range of areas. Okay, so this is not only sort of not only do our researchers get involved with industry, as it were, this means that there are opportunities for you students to be involved in research projects such as these, as it were, to help actually apply the mathematics to solve real-world problems in useful ways. Okay, so I think that's all I wanted to say at the moment. So just to mention that I'm very happy to keep in touch with you. If you want to get in touch directly, that's my email address. If you want to sort of queries about admissions, there's Maths Admissions is probably the best email address. That comes directly to me at the moment, but it is viewed by others if I'm away. And there are various ways you can keep in touch via social media as well. Okay, thanks very much for listening. I'll hand you over to Robin now, who I think will be talking to Aled, Jack and Patience.